Okay, let us start our class. So in today's class, we'll discuss about the pavement materials, and there are different types of basically pavement materials like soils, aggregates, bitumen, okay, or cement, etc. So among these different pavement materials have different tests associated with it, and why these tests are required. Basically, these tests are required to find out the characteristics of the material to know whether they are suitable for the construction or not. Okay. Now, so in this class, we'll discuss about the soils and aggregate as a pavement materials and different tests associated with soils and aggregates to know their suitability as a pavement material. Now, before starting this pavement material, let us discuss about the different layers of flexible pavement. So basically, there are two types of pavement: flexible pavement and rigid pavement. So flexible pavement is the type of pavement where bituminous materials are used as a top portion or surfacing, and rigid pavement is where cement concrete is provided. Now, if we consider about the different layers of the flexible pavement, in that case, the bottom layer, okay, the bottom layer would be your subgrade layer. So basically, this subgrade layer is the underneath soil layer. It may be a type of the embankment or some deep in the ground. Okay, so basically, subgrade layer is the soil layer. So above this layer, another layer would be there, which is made up of crushed aggregate, and it is called subbase layer. Okay, then above this another layer would be there. Okay, this is also made up of aggregates, but the size of the aggregate would be lower than the surface layer, and this layer is base layer, and above this we have surfacing course. Okay, above this that would be surfacing. And now this surfacing can be made up of cement concrete or bituminous concrete. Bituminous concrete means bitumen mixed with the aggregate. Okay, now these are the different layers of the flexible pavement. So as all this load, if you consider about the distribution of the load, suppose vehicles loads are applying over here. Now this load will gradually go down, and ultimately it will be borne by the subgrade layer. Therefore, this subgrade layer is very much important in retaining the integrity of a flexible pavement. Okay, and as the subgrade layer is made up of the soil particle, therefore we need to know about the different properties of the soil and suitability of the soil as a subgrade material. Now, there are different types of soil. So these are the different classification. I'm not going to discuss about the detailing of these types. because this is already included in your soil mechanics chapters. So I'll not discuss all these things. You just go through all these notes. Now, if you go for the tests on the soil, so for the pavement material, we have very two important tests. Okay, one is California bearing ratio test or severe test, and another one is plate load test. So California bearing ratio test is basically a penetration test which is used to know the subgrade strength of a soil, and this test is a laboratory test. Okay, there are two types of California bearing ratio test. One is soaked severe test and another one is unsoaked severe test. Okay, in the soaked severe test, what happens? Whatever sample you have prepared, you have to go for the soaking for a period of 4 days. Okay, and for the unsoaked severe test, you don't have to go for the soaking in the water. So basically, these are the difference between the soaked severe and unsoaked severe test. Now, how this test is performed? So basically, for the severe test, we need at least 5 kg of the soil sample, and these soil samples can be collected from the appropriate section of the road. Okay, suppose you are making a road, so over there from the separate layer you can collect the soil sample. Now after collecting the soil sample, what you have to do? First you have to mix water with the soil sample. Now at which quantity you have to mix the water? The quantity would be the optimum moisture content. Okay, optimum moisture content. Why optimum moisture content? Because at the optimum moisture content, the dry density would be maximum. So therefore, you have to mix water with the soil sample with a quantity of optimum moisture content. After that, there would be one mold. This is the mold where you need to place the soil sample in 3-layer assembly. Okay, in a 3-layer assembly. So first layer, second layer and third layer. Now in each layer there would be one hammer, and the weight of the hammer would be like 2.5 kg. In each layer you have to compact the portion or compact the soil sample with 25 numbers of hammering blows. So after 25 number of blows in the first layer, you can place the second layer. Then again, you have to go for the 25 number of blows and then again third layer. Now after putting the third layer, you have to cut the excess soil particle from the mold. And after that, you have to place one collar plate, okay, and a surcharge load over the soil sample. Okay, you have to place one surcharge load. This is the surcharge load over the soil sample. Now, basically, if you go for the top view of the surcharge load, it would be like that. Okay. Now, the diameter of this hole would be nearly 50 mm, 51 or 52 mm, slightly greater than the 50 mm. Now, why? Because there will be one plunger associated with the instrument. Okay, this is the basically instrument. So there would be one plunger associated with the instrument, and basically this is the standard penetration plunger through which load will be transmitted to the soil sample. Now the diameter of this plunger is 50 mm. Now there will be two dial gauge attached with the with the instrument. One dial gauge would be over here, which will take the reading of the load, and another dial gauge would be over here, which will be taking the displacement reading. Displacement reading, why? Because when you are applying the load, in that case what will happen? The soil sample will get compacted, okay, and it will be displaced. So here, therefore this dial gauge reading will give you the displacement reading. After that, you need to record all the loading values for different standard displacement or standard penetration values. Now there are different standard penetration values. So these penetration values are like 0, 0 point like 0, then 0.5 mm, then 1 mm, 1.5 mm, then 2, 2.5, 3, 4, 5, 7.5, 10, 12.5. So basically, all these readings are the standard penetration value or standard displacement value, and all these values are in millimeter. So how you have to take the load readings? So you will start the machine. Whenever the displacement is 0, you need to take what is the load value. So basically for the 0 displacement, there would be load value also be 0. After that, you have to find out what is the load reading for a 0.5 mm of the displacement reading, and you have to note it down. Again, you need to note it out what is the displacement load value corresponding to a 1 mm displacement value, and again you have to take that reading. So similarly, for all these displacement value or penetration values, you have to take the reading. Now severe value is generally taken as 2.5 mm penetration or 5 mm penetration, and the definition for the severe value would be load value at 2.5 mm penetration divided by standard load. Now generally this standard load value for 2.5 mm penetration is considered as or found to be 1370 kg. Okay, now again you have to find out what is the severe value corresponding to 5 mm penetration value, corresponding to 5 mm penetration value. Okay, corresponding to 5 mm penetration value, and for the 5 mm penetration value, the load reading is standard load reading is 2055 kg. Okay, and you need to tally both the reading. Generally it is always expected that 2.5 mm corresponding severe value would be larger than the 5 mm penetration value. But if the opposite happens, that if the 5 mm penetration value or 5 mm severe value is more than the 2.5 mm penetration severe value, in that case you have to repeat the test. Now if you repeat the test, and again after repeating the test you got the similar result, in that case you have to consider the 5 mm penetration value as for the severe value. So this is all about the severe test. Now another test is there, and this is called plate bearing test. Okay, so why it is called plate bearing test? Because one larger plate, some plate or assembly of plates are associated with the test, and over this plate some load will be there. Okay, and for this reason it is called plate bearing test. So basically severe test was your laboratory test, but plate bearing test is a in situ test. And from the plate bearing test you need get an idea about the modulus of the subgrade reaction. Now plate bearing test is used to evaluate the support capability of subgrades, bases, and in some cases complete pavement. Now severe test was only conducted for the subgrade courses, but the plate bearing test can be done for the subgrade bases and some cases complete pavement. Now data from the tests are applicable for the design of both flexible and rigid pavements. Now in the plate load test, what happens? A compressive stress is applied to the soil or pavement layer through a rigid plates relatively larger size, and the deflections are measured for various stress values. Now, suppose this is the plate. Over the plate, some load assembly would be there, and upon applying the load assembly, you will get to know, or you have to record what is the corresponding deflection value for the different loading values. Now, this deflection level is generally limited to a low value in the order of 1.25 to 5 mm, so that deformation cost may be partially elastic and partially plastic. So elastic means whatever deformation was there, that deformation got completely recovered. Okay, and plastic means whatever deformation is there, it will be sustaining of it. Okay, now the plate bearing test has been devised to evaluate the supporting power of the subgrades or any other pavement layer by using of plates of larger diameter. Generally, the diameter of the plate would be 750 mm, and this plate bearing test is very much important test to find out the different parameters for the rigid paper, which we'll discuss in the next chapter. Now, these two are the important soil separate test. So another type of test is there, that is triaxial test. That test is also performed to know the various characteristics of the soil sample. Now coming to the next portion, aggregates. Now aggregates for the flexible pavement is very important. Now in the flexible pavement, as we have discussed earlier in this chapter, that there are two layers of the aggregates. One is your subbase layer and another one is base layer. Now in the subbase layer and in the base layer, what happens? We will use only the well graded aggregates, and we will not use any type of cementing material or bituminous material. So therefore the grading of the aggregate should be very much good, because in such cases what happens, the aggregate get together with a property which is called interlocking property. Now this interlocking property of the aggregate is affected by the size and shape of the aggregate. Therefore, for the pavement material, size and the shape of the aggregate is very much important. Moreover, as the aggregates are in direct contact with the loading condition, that is, they are also exposed to the surface conditions, therefore, they need to be very much hard, durable, and tough to withstand all the different adverse conditions which may appear over the years. Okay, therefore the properties of the aggregate should be checked thoroughly before applying this for the road materials. Now there are different types of desirable properties for the aggregate. So first one is, which you have to check, first one is hardness. Now hardness, the aggregate used in the surface course are subjected to constant rubbing or abrasion due to moving traffic. Abrasion means, suppose these are the aggregates assemblies are there. Now, if load is applied over there, okay, in that case, what will happen? These surfaces of both this aggregate will be rubbing each other in transmitting the load, and that will create some abrasive action. Okay, now to resist this, okay, or to eliminate the effect of the abrasion, uh, the aggregate must have hard enough to resist all this effect, because due to the excess abrasion, what happens, the aggregate got deteriorated and it can become some dust particles. So therefore, the aggregate must be hard enough to resist these abrasive actions. Then another property is toughness. So toughness is resistance of the aggregate to impact. Now what is impact? Impact is the sudden application of the load. Okay, or the load which is applied at an instant time. So aggregate used in the pavement should be able to resist the effect caused by the jumping of the steel tire wheels from one particle to another at different level causes severe impact on the aggregate. So what does this mean? This means that suppose this is the road. Now in the road there will be different undulations. So whenever a vehicle would be moving over such type of road, in that case what will happen, because of the undulation, in some cases the vehicle may jump for a momentarily time. Okay, so in this way what will happen, when this tire will again, after jumping again, touches the pavement surface, it will create some impact. Okay, so therefore the aggregate must be impact resistant to withstand this type of load. Okay, so this is your toughness. Now shape of the aggregate we have already discussed why shape of the aggregate is very much important. Now shape of the aggregates are checked with the help of two tests, which is called flakiness index test and elongation index test. Now adhesion with bitumen, how bitumen and aggregate will mix together, that is adhesion with the bitumen. Then durability is the property of aggregate to withstand adverse action of weather condition. Okay, now the aggregates are subjected to physical and chemical action of rain and bottom water, impurities from the surfaces and in the aggregates also. So therefore you need to check whether the aggregates are durable enough or not. Now coming to the test, so first test is crushing test. Now why crushing test is conducted? Crushing test is conducted to know the strength of the aggregate, and basically this crushing test is conducted in a compressive testing machine where you put the aggregate in a mold and they will be subjected to compressive forces. Now after a particular time or after a standard loading value, you have to check what is the percentage of crushed particle in corresponding with the total aggregates. Okay, and that will give you the crushing value test or crushing percentage. Then coming to the next portion, abrasion test. Now abrasion test is conducted, to find out the hardness properties of the aggregate, and abrasion test is conducted using your different type of machines. So two popular instruments are Devil abrasion test and your Los Angeles abrasion test. So basically in both the test, what happens, one large size drum shaped metallic drum would be there, where you will put the aggregate along with some abrasive charges. Now what are these abrasive charges? Abrasive charges are nothing but some steel balls, and that drum will keep rotating. After a standard rotation, you will check what is the number of crushed particles with respect to the total aggregate. Okay, and that will give you the abrasion percentage. Now another test is impact test. Now in the impact test, what happens, you will put the aggregate in a mold, and there will be one hammer of like 20 kg or 22.5 kg, and you will keep hammering the aggregate, and after 15 number of blows you need to check out what is the total percentage of crushed particles. The next test is soundness test. Now this soundness test is intended to study the resistance of aggregate to weathering action by conducting accelerated weathering test cycles. So basically in this test what happens, whatever aggregates that is there, that type of aggregate would be subjected to different type of freezing and heating cycles, okay, and to find out the durability of the aggregate. Then coming to the next portion, shape test. Now shape test is, there are two types of shape test. One is flakiness index test and another one is elongation index test. So in the flakiness index test, what happens? You need to find out what is the flaky particles. Now the definition of the flaky particles is, let me first discuss one thing about the particle size. Suppose Suppose this is a standard shape. Now in the standard shape, there are three dimensions. One dimension is length. Okay, one is length, another one is width, and another one is depth. So basically these are the three dimensions. Now if I tell you to find out what is the average dimension, in that case what you have to do, you have to add up length plus width plus depth divided by 3. That is the average dimension. Now in the flaky aggregate, what happens, the depth would be it would be very thin, or depth would be very less. Okay, so the definition of the flaky aggregate would be the aggregates whose least dimension, here least dimension is the depth, least dimension is lesser than 0.6 times of the mean dimension. Mean dimension means average dimension. These are the flaky particles. Now another type of aggregate is elongated particles. As the name suggests, elongated particles would be longer. Okay, now here the definition is the particle whose greatest dimension is length, is more than 1.8 times of their mean dimension. Okay, this is elongation index. Now another test is, very important test is specific gravity test and water absorption test. So from the specific gravity test we get to know about a rough idea about the hardness properties of the aggregate. Okay, and water absorption test also, it is very much important to find out whether the aggregates are within their limit or not. Now these are different properties of the aggregate. These are the different types of tests, and these are the test methods which are followed in Indian conditions. Okay, is it clear to you? Hello, you can leave the class.